All right, we're going to look at 5.2, and if you want to write these things down, fine. If you just want to listen to the discussion about this vocabulary. The first word that I want to make sure you understand when I use it is the word, thought I had a highlighter, is the word term. A term is a number or a product of numbers and variables raised to powers. All right, for example, I'm going to put a couple of examples up here. A term could be just a number, like 5. That's a term. It could be 6x. That's the product of a number and a variable. It could be 7xy squared. Those are all examples of terms. To me, they're a little bit like in an English, if you're talking about the English language, they would be like words. Terms are like words. In a term, there is something called a numerical coefficient, sometimes just referred to as a coefficient. And it is the numerical factor. So I'm going to write down a term. Suppose I have 5x. What is the coefficient in that term? Okay, not the opposite. Okay, the numerical coefficient is just the numerical factor. That's all it is. So the coefficient is just the 5. It's just the number part of the term. So if I had negative 17xy to the 5th, what would the coefficient be? Negative 17. It does keep its sign. What if I had the term x? 1. Its numerical coefficient is 1. It's implied. It's not printed. What about if I had negative z? Negative 1. It's another implied coefficient. And what if I had a constant? 6. It is 6. 6 is considered its own numerical coefficient. So if I talk about do something with the coefficients, I'm talking about just the number parts.
How come you wouldn't do nothing with the 5 on top of the y?
Okay, that's the exponent, and the numerical coefficient is a factor, meaning it's something being multiplied. Okay? All right, let's look at the next, which can sometimes be considered a confusing word, but I hope it won't be for us. It is a polynomial. A polynomial is a finite, and that means it is a countable number of sum of terms in which all the variables have exponents raised to non-negative integer powers. Non-negative integers. You know what those are? Those are the whole numbers. 0, 1, 2, 3, 4, and so on. And no variables appear in the denominator. Let me translate that into English for you. A polynomial is a sum. Now, since it can be the sum of positives and negatives, some people might say it is a sum or a difference of a bunch of terms. So it is things like 5x plus 3. That is a polynomial. A polynomial is kind of like a phrase. What's a phrase made up of? A bunch of words attached together? That makes a phrase. A polynomial is like a phrase, except that it's mathematical and it's made of a bunch of terms added together. Now, I say a bunch of terms. Actually, a polynomial can be a single term. It could be 6. A polynomial can be 17x to the 5th plus 5x to the 4th minus 9x to the 3rd minus 8. That's a polynomial. A polynomial is a collection with addition and or subtraction of a bunch of terms. or maybe just one term. Those are polynomials. They're made up of terms. Is that okay? All right. A function, we've talked about functions. We used them when we talked about function notation. A function p is a polynomial function if p of x is a polynomial. Okay, I'm going to translate that. Polynomial function. An example. What if I had p of x is equal to x squared plus 3x minus 7? It is a function. It is in function notation. And the right-hand side, do you agree that this is a polynomial? Yes, it is a polynomial. Could I ask you to find p of 2? And if I ask you to find that, what am I asking you to do? Put a 2 in there everywhere there was an x. So that's 2 squared plus 3 times 2 minus 7. Then you would use Aunt Sally's order of operations and say that's 4 plus 6 minus 7, which is 3. P of 2 is 3. Is that okay? All right, so we will look at some polynomial functions in this lesson. Degree of a term. All right, we know what a term is. It's kind of like a mathematical word, and it can be made up of numbers or numbers times variables. The degree of the term is the sum of the exponents on the variables of the term. So I'm going to write down a term, and I want us to figure out what its degree is. What if I have 5x squared? All right, the degree is the sum of the exponents on the variables. Well, there's only one variable. There's only one exponent. So what will the degree be? It will be the 2 of the x squared. So the degree will be a number. What if I had 3x to the 5th, y to the 4th?
20.
Okay, go back and look. The definition, it is the sum, so it will be 9. So if you have a single variable in your term, it is the variable's exponent. If you have a product of variables, it is the sum of their exponents. If you had, say, 3x, what would its degree be? 1, yes, because there is an implied exponent of 1, even though it's not written. Finally, what if I have 8, the constant number 8? It would be 0. The degree of a constant is 0. Now, if I wrote in red an x, what would its power have to be? Well, y'all just told me it was 0. Because what is x to the 0? Not 0. It's 1. We have to go back to Monday's lesson. Any base to the 0 power is 1, and then what's 8 times 1? 8. Okay, so what you need to remember, though, the degree of a constant is 0. Okay? Now, that was, keep doing that. Keep trying to get highlighter and just marking things out. That was degree. Did all my stuff just go away?
So that last one, the degree of a 0 would be 1.
Yes. Oh, where did all my stuff go? Come back. I'm hitting the undo button. I have so undone it. Okay, well, I hope you got it while it was there.
Got it.
Okay? That's upsetting. If you look at the printed notes that are out there under lecture notes, it's all still printed. I don't know how I did that. I have to make sure I don't do that again. All right, degree of a polynomial. The degree of a polynomial Now we just finished with degree of a term. It disappeared, but we had done it. The degree of the term is the sum of the powers on the exponent, on the variables. The degree of a polynomial is the greatest degree of any term of the polynomial. It is the greatest degree. So here's how you do it for a polynomial. I have, suppose, 5x to the third, y to the fourth, plus 7xy minus 18z. And somebody says, I want to know the degree of the entire polynomial. Well, to determine the degree of the polynomial, what you do is get the degree of each term first. What would be the degree of this term? 7. And of this term, 2. And of this term,
1.
the degree of the polynomial is the greatest degree of any of the terms. So the degree is 7. You don't add them, you don't do anything with them. You look at all the terms and you say, who wins? I'll pick that one. It's the greatest. Is that okay? And we're not going to look at this on this page of notes. All right, so everything else disappeared, but we saw it at some point. And we're going to take a look at the My Math Lab. Oh, there is one more thing. Let me go back. Sorry. I want to add something. I want to talk about classifying. Look at that. It erased again. I wonder what's up. That's scaring me. Okay, classifying polynomials. And I'm going to abbreviate that as poly. All right, we classify polynomials by the number of terms they have. So if I have one term in a polynomial, we use the prefix mono. So it is a monomial. If we have a polynomial with 2 terms, we use the prefix bi, and it's called a binomial. If we have 3 terms, what do you think it might be called? Yes, it is a trinomial. There are no other names. So the general name is polynomial, with the prefix poly usually means many. So we can have special names for special polynomials, and then all the rest of them are just polynomials. Okay. I'm going to enlarge this a little bit for the people in class. Let me try one more zoom. Okay. Question number 1. And I will read it in case you have difficulty seeing it from the back of the room. It says, find the degree of the following polynomial and determine whether it is a, and then what you can't see on the screen up there is monomial, binomial, trinomial, or none of these. All right, the polynomial is 3x plus 8. It is degree 1. Now, how did we come up with a 1? Well, the degree of the first term is 1. The degree of the second term is 0, and you pick the big one. The degree of the polynomial is the greatest, so it is 1. Okay. Now it says choose the correct type of polynomial. Well, how many terms does it have? 2. So it is a binomial. So you will choose either trinomial, monomial, binomial, and if none of those work, then you choose the option none of these. Okay, problem number 2. Find the degree of the polynomial and determine whether it is Monomial, binomial, trinomial, or none of these. All right. This is, and I'll write it larger, 4m to the fourth minus 2m to the third minus 3m squared minus 10m minus 6. All right. If I'm going to determine the degree of this polynomial, then I need to look at the degrees of the individual terms. The first one is degree 4, then 3, then 2, then 1, and 0. So what is the degree of the polynomial?
4.
It is 4, because it is the greatest of all those degrees. Next, it asks me to classify it. Well, let's count the terms. There are 1, 2, 3, 4, 5. Since there are 5 terms, it's none of these. There's not a special name. You know, you might think it would be a polynomial, but it's, I could make up a name for it, but it's not one. All right? Would you look at number 3, and I will rewrite it larger, and then if you'll think about the answers. I have 2y z to the third minus 6y squared z plus 5y to the fifth z. If we're going to get its degree, we need to know the degree of each term. What's the degree of the first term?
1.
Okay, now we have to be careful. The degree of this term, this is an implied 1. You add it to the 3 for an entire degree for this term of 4. The next one has a 2 and an implied 1 for a degree of 3. This one has a 5 plus a 1 for a degree of 6. So now what's the degree of the polynomial? 6.
Wait, so why are we adding them now?
The definition of degree of a term is the sum of the powers. So for an individual term, you add the powers. But for a whole polynomial, you just pick the big one. Okay? Now, if we can look at that polynomial again, can we classify it? Let's see, how many terms does it have? It has 1, 2, 3, so it is a trinomial. And so we're through with the concept for right now of degrees and classifying. But periodically through this course and your future courses, people will talk about, well, what degree is this polynomial? Well, is it a monomial? Or let's look at these binomials. And you need to have an understanding of what that language means. All right, let's go on. A little bit more on degrees, but we're not classifying, just looking at degrees. This next polynomial is 4xy squared minus 2. I want to know the degree.
3.
It is 3. The degree of the first term is 3. The degree of the second term is 0. And so the degree of the polynomial is 3, because we picked the big one. Number 5.
7.
Yes, it is 4a to the 7th plus 2a minus 5. And I'm trying to rewrite these because people in the back of the room, there is no way they can read this. Y'all can up front, but they can't in the back. And so the degree, this is a 7, this is an implied 1, this is an implied 0, and you were right when you said it was 7. All right, the next couple of questions are about function notation, polynomial function notation. So I start out with p of x is x squared plus x plus 2. And I'm asked to find p of 7. It will be 7 squared plus 7 plus 2. Now, It did not make any difference in this particular polynomial function with the particular number 7. It didn't matter whether I used parentheses here or not. If it had been a negative number, it might have made a difference. So this will be 49 plus 7 plus 2, which is 58. So the answer is 58. Is that okay? Function notation. Problem number 7 has the polynomial function called q of x, because really a function can have any name. Q of x is 3x squared minus a 1. And I'm supposed to find q of negative 10. So I have 3 parentheses, negative 10 squared minus a 1. What is negative 10 squared?
20.
Multiply? 100. So it's going to be 3 times 100 minus 1. 300 minus 1 is? 299. Now, if you were, now I know that you squared the negative 10 in your head. You didn't use a calculator. But if you did use a calculator to square a negative number, you would need to make sure you put it in parentheses to square it, because otherwise it will not think it's negative 10 squared. It will think it's the opposite of 10 squared, which we talked about on Monday. So just be cautious of that. And finally, number 8, last one of the polynomial functions, p of x is x squared plus x plus 1. And you're asked to find p of 0. Well, that's 0 squared plus 0 plus 1, which is 1.
What number is that right there?
That is number 8. The last several problems in lesson 5.2 have to do with addition and subtraction. And I'm not going to make a real big deal out of this because you've really already done this skill. You add and subtract polynomials by, and I'm going to highlight this, combining like terms. What does it mean to be a like term? Yes, same variable. That's probably off the visible screen up there. It is the same variable with same exponent. Yes, they do. So an x squared is like some other x squared, but an x squared is not like an x to the 4th. Okay, so same variable with same exponent. And when you combine them, all you combine are the coefficients. Okay, so this should look somewhat familiar. You've done it before, it's just been plain old x's or plain old constants. All right, number 9, and if I rewrite that, I have 17x squared plus 2x squared. You would have to ask yourself first, are they like terms?
Yes.
So I have a monomial plus a monomial. I combine like terms, 19x squared. And make sure that the answer you get when you've combined like terms has the same variable and the same exponent as the ones that added up to get it. Kind of like when you get a common denominator and you add fractions with the common denominator, you keep the common denominator. You keep this like term.
So you're only adding like the
Numerical coefficients, the numbers. Yes. Okay, that was number 9. Let's look at number 10. Number 10 says simplify the given polynomial by combining like terms. I have 2x to the second minus 4x to the second minus y. You're right. Are all of those terms like terms?
No.
No. There is a 2x squared and there is a negative 4x squared, and those are like terms. So I have positive 2 and negative 4 using my addition rules. I get negative 2x squared. Well, how about the minus y squared? It's just minus y. I think I said y squared. There is no square. The minus y, he just doesn't have any friends, so he just hangs on. Don't lose his sign. So I'm going to combine like terms to add and subtract polynomials. Okay, number 11. Simplify by combining like terms. I have 2x minus 3x plus 8x. Are they like terms?
Yes.
All of them are. So I have positive 2 and negative 3, which is negative 1x, plus 8x is,
Negative 7x.
it is positive 7x. You can do those in any order you want. If you wanted to, you could have added up the two positive terms for 10x and then subtracted the 3 to give you the 7x. Do it any way you want. Now, number 12. Number 12 has got a binomial minus a binomial. You don't have to even think about the fact that those were binomials. I'm going to rewrite it so we can all see it a little bit better. I have 7x squared plus 3, that's in parentheses, minus, parentheses, 12x squared minus 6. When I see all those parentheses and someone asks me to simplify, I don't know about you, but I think about the distributive property. So I'm going to look in front of the first set of parentheses. What do you see? Nothing, which means it's an implied 1. 1's the identity, so I can take those parentheses off and you don't see any change. What do you see in front of the second group? A negative, so it's a negative 1. If I distribute that, what will that cause when I multiply?
Negative.
The signs will change. So I have negative 1 times 12x squared is negative 12x squared. What's negative 1 times negative 6? Positive 6. So anytime the parentheses are preceded by a negative, in other words, when you're subtracting, the signs all change in the second one. Now, do you have any like terms?
Yes. 7x and 12x.
You have 7x and 12x, and then we'll have the 3 and the 6. So I've used my colors to try to group the like terms. How many x squareds will I end up with? Negative 5, x squared, and constants plus 9. Is that okay? All right. Let's look at the next problem. I'm asked to subtract. This is number 13. I have 6x minus parentheses 11x minus 6. If you want to use a shortcut rather than making it look like distributive property, you can do the following. I'm going to do this in red. You keep any term which is preceded by either a positive or a nothing. But if parentheses are preceded by a negative, you can simply do this. Change that to a plus and change all of the signs inside to their opposite. That's as if you've distributed the negative inside. So I have 6x minus 11x plus 6. And if I looked back at the original problem, the positive 11x changed to a negative 11x. The negative 6 changed to positive 6. Now, do I have any like terms to combine?
6x, 11x.
Yes, I have 6x and negative 11x, which gives me negative 5x, and I have the constant 6, which does not have any buddies to combine with. Now, I've shown these two problems two different ways. On this problem, I physically showed the distributive property with the -1. If that works best for you, then use it. If you prefer, you can simply change that minus to a plus by distributing the sign, changing all the second signs. Okay, the next problem, and let's see, I'm on number 14 now. It's written in words, so you need to be able to translate. And on your test yesterday, I said something at the beginning of class about the phrase, all I said was, remember the phrase less than. Think about what that means. Well, it means subtraction, but it means reverse. Just like subtract from, less than means reverse. And not everybody remembered it, and I probably wrote you a little note on your test. Okay, this one says subtract 2x plus 8 from the sum of 3x plus 7 and 4x plus 5. What am I going to write down first?
3x plus 7.
Okay, I'm going to write down that this is 3x plus 7 plus 4x plus 5, and that's the sum. And I'm going to subtract from it 2x plus 8. Thanks. Okay, so first I have to be able to translate, and subtract from says to put this at the back. Do I have to worry about any signs in here in the first group? Nope, that's just going to be 3x plus 7. The second group, preceded by a plus, no worry, plus 4x plus 5. What about the last group? Yes, the signs are going to change. You can either do the distributive property, or you can say, I'm going to make it be add the opposite of the second one, or the last one in this case. That gives me minus 2x and a minus 8. Just about everybody changes the sign on the first one, but I see mistakes when people don't change the sign on the last term. All right, do you see some like terms? Let's see if I can squeak it in. I have 3x plus 4x, which is 7. Minus 2 is 5x. And then for my constants, I have a plus 5 and a minus 8, minus 3. Is that what y'all got? Oh, no, because I neglected this guy. So maybe I need to stick with the idea of making little marks, because obviously I'm overlooking things. Just hope everything doesn't erase this time. All right, so how about 7 plus 5 is 12, and 12 minus 8 is plus 4. Y'all were trying real hard to get me to write plus 4, and I was ignoring you, and you were so right. Is that okay? All right. I may have difficulty getting this next problem all written out. Let's see if I can do this. Let's see if I can enlarge it. Okay. This is problem 15. I have 3x squared plus 6x minus 2, a plus sign, 4x squared plus 5x plus 13, a minus sign, 7x squared minus 17. So if I'm going to do the addition and subtraction, none of the signs in the first polynomials change. But what about in the last one? Yes. So let's see. I'm going to change this to plus. Then I'm going to change the 7x squared to minus. And I'm going to change the minus 17 to plus. Let's see, and y'all help me collect like terms. All right, x squareds. I have 3 plus 4, which is 7, x squared, minus 7x squared, and he's exactly right when he said they cancel out. All of the x squared terms cancel out, and you get 0x squared. You don't write x. You don't write it at all. All right, the x's. I have 6 plus 5. All right, that's it for those. So 11x. I'll go off to the side and write 11x. All right, constants. I have a minus 2, a plus 13. That gives me what? 11. Plus 17. 11 plus 17 is 28. The sum and the difference gave me 11x plus 28. All right, problem 16. It says subtract 6x plus 9 from 6x squared plus 4x plus 6. What am I going to write down first?
6x squared.
Yeah, 6x squared plus 4x plus 6. And I'm going to subtract 6x plus 9. What do I have to do to the first group? Nothing. The second group,
Change the sign.
change the signs because it's preceded by a minus. So I'll change that to plus, minus 6x, minus 9. Combining. Now, do I have any other x squareds to go with the 6x squared? No. So I have 6x squared for my first term. Do I have any like terms with the 4x?
Yes.
Yes, I have a minus 6x. So what does that give me?
Minus 2x.
Minus 2x. So I have 6x squared minus 2x. And now looking at constants, I have plus 6 and minus 9, which is negative 3. I don't know if I can get all of this. No. The last one, I can't get all of it on the projection screen, and y'all may have difficulty seeing it. It says to subtract, and it gives me a trinomial right here, from the sum of, and it gives me 2 more polynomials. So what am I going to put down first? That sum, okay? So I'll write large for us to see. I have negative 5x squared minus 6x plus 8x squared plus 4x plus 3. And then I subtract from that negative 9x squared plus 2x minus 7. And I can't make it all show up at once. There it is. I don't worry about the signs in the first one because it's preceded by a positive. I don't worry about the signs in the second because it's preceded by a positive. But what about the last one? I need to change all these signs. This will become positive. This will be a plus 9x squared, a minus 2x, and a plus 7. So when I combine like terms, and let's always put our terms in what's called descending order. Highest power first, constants last. X squareds. Negative 5, positive 8, and positive 9. What does that give me? 12x squared. Whoops. Nice, pretty green. All right. Let's look at our x's. We have negative 6x, positive 4x, and negative 2. Yes. That's going to give us negative 4x. Constants. I have a plus 3 and a plus 7. plus 10. I think you can imagine that you have to be especially careful when the problem has subtraction in it. Change your signs, then combine your like terms. And that concludes lesson 5.2.